Now we're going to continue with a new resistor combination. Notice we have the 10-volt supply. We have the same three resistors, a 12 ohm, 20 ohm, 18 ohm, but they are arranged differently this time. So the goal again is going to be to find the current, the voltage drop through each, or the current through each resistor, the voltage drop across each resistor. Where do we start? Well, we could start with a 12 ohm if we wanted to, because clearly the 12 ohm, if I put red here, I put blue here, I would conclude that the voltage drop across the 12 ohm, right, if you do your Kirchhoff loop like that, it has to be, that voltage drop has to be, let's see, what color am I using for this? I think for this one I use minus 10 volt. Because if you go up 10, you go down 10. So the 12 ohm we solve pretty quickly. Well, let's get the current for the 12 ohm as well. You see, because of the way things simplify when you have things in parallel, I can ignore the 20 and the 18 for now, because I know there's 10 volts across the 12 ohm resistor. So I know the current is going to flow for this thing. Well, it's going to split. Let's go I1, then there's going to be another portion, I2. For this I1 portion, let's solve that. We're taking a different approach than I took on the previous one. The previous one, I said, let's solve for the equivalent resistance step by step. This one, when you see something that's just jumps out like that, you see the 12 ohm, I can draw a loop from the 10 volt to 12 ohm and see what's going on. That it has to be a 10 volt drop. My loop, remember the Kirchhoff loop rule applies for any loop you can draw in a circuit. You can draw the loop and ignore the things that are not in the loop. The 20 and the 18 are not in the loop I'm considering. So let's consider what the current I1 would be for that 12 ohm resistor. It's going to be a voltage drop minus I1 times 12 ohms equals minus 10 volts. Minus sign cancels out. I1 is going to be 10 over 12, 0.83 amps. Put it here, 0.83 amp. Okay. Now, to make progress with the rest, we're going to have to do some more work. What you should see here is this current I've drawn as I2 is going to go through the 20 ohm, I'm going to pass down, go through the 18 ohm, come back, join up. The 20 and the 18 are clearly in series. Whatever goes to the 20 must go to the 18. Remember, in parallel, same voltage. In series, same current. They're in series, so we're going to use the rule for series, which is, of course, the simple one. Our series is just the sum of the two. It's going to be 20 plus 18 equals 38 ohms. Now I'm going to do the step of redrawing the circuit. So I'll come here, 10 volt supply. I come around, now I've got my first loop, which has a 20 ohm resistor. I'm sorry, it's a 12 ohm resistor. Need to look closely. That's the 12 ohm. This other portion, I have taken the 20 and the 18 and I'm replacing them with an equivalent 38. Okay, these two are clearly in parallel. So I can solve for my REQ. Remember, in parallel, it's 1 over REQ equals 1 over 12 plus 1 over 18. I'm not going to work through the fractions. I'm going to tell you that the equivalent, the REQ for this one is going to be 9.12 ohms. Okay, 9.12 ohms. So I can draw this. Actually, at this point, I can solve the problem without going further. I don't need to redraw the circuit. Here's why. If you need to know REQ for this circuit, well, I know that this is equivalent to this right here. Ohms. That's what it's equivalent to. But I can solve quite a bit without even taking that last step. And here's why. Look at this circuit right here, the parallel. My old trick of saying, let's consider everything here on the top is red. Everything on the bottom as blue. I can see red to blue, 10 volts. Red to blue, 10 volts for the 12 ohm. Red to blue, 10 volt for the 38. Of course, their voltage drops. If I consider loops, let me switch to green right here. Or not green. You see, I could take this as a Kirchhoff loop. I know if I go up 10 volts, I'm going to drop 10 volts there. But if I erase that one and choose another Kirchhoff loop, I start here, go like that. Any loop you draw, the same thing applies. Left side, you go up 10. Over here, I have to drop 10 volts. I know it's a 10 volt drop across that 38 ohm. Therefore, I can figure out the current that goes through that 38 ohm resistor. It's going to be a current drop. So it's going to be minus 10 volts minus, remember this is what I call I2 minus I2 times 38 ohm. I2, negative signs cancel out, 10 over 38, 0.263 amp. So minus 10 volts, 0.263 amp. The other one I said was 0.83 amp. I realize I'm not being consistent with my significant figures, but I would encourage you to work along as you watch the video with your calculator and be more consistent than I am with the significant figures. Actually, I can update this a little bit. This I can add a figure here to be consistent. Oh, lost my resistor. The current there is actually 0.833 amp. 0.833 amp. So the total current flowing through the circuit, of course, go back here now. The current that flows through here, let me put it here, that's a 10-volt drop with a current 0.833 amp through the 12-ohm resistor. That's what I call I1. I2, 0.263. You said, but that's the 38 ohm. Yes, the 38 ohm is equivalent to the 20 and 18 in series. Remember, when we do things in parallel, we apply the same voltage. In series, we apply the same current. So I know that this is going to be 0.263 amp through this resistor, 0.263 amp through this resistor. Using the junction rule, I can solve for the total current I that goes from and back to the battery. The total current I, this I, here if you go to the battery, this current that leaves the battery comes to this point here, splits in I1 and I2. Junction rule tells me I equals I1 plus I2 equals 0.833 plus 0.263 equals, and let's see, total current, I'm going to do some rounding here, 1.10 amp. Round, I don't want to keep too many digits, so 1.10 amp, which leaves the battery. Leaves the battery. It travels up and it splits into I1, 0.833 amp through the 12 ohm, and then I2, 0.263 amp through the 20 and the 18. Of course, the other thing we want to solve for are the voltage drops across those other resistors. We see the current flowing through the resistor. Assuming we go clockwise, we've been going clockwise, we follow the current, the voltage drop is going to be minus 0.263 amp times 20 ohm. That voltage drop will be minus 5.26 volts. Okay, put it here, minus 5.26 volts. The voltage drop for the other resistor, remember, if you follow the current, we expect minus I times I2 times R, which is 18 ohm. Remember Ohm's law, delta V is I times R, but if we're tracking through a resistor in the direction of current flowing downhill, it's going to be a decrease in potential minus I times R. So we find that this is equal to I2, which is, oh, well, let's put in the I. We know what I2 is. I'll just go ahead and write it again. I2 is 0.263 amp times 18 ohms equals minus 4.74 volts. We come back here, minus 4.74 volts. Okay. Now, let me just do a little bit extra here. Application of the Kirchhoff loop rule. Once again, if we consider, got some colors, I'm going to use green this time. I start here. I'm going to do my trip around the loop. So if I go up this side, that's plus 10 volts. If I travel along here, when I go through the 20 ohm resistor, minus 5.26 volts. I come down this side through the 18 ohm resistor, minus 4.74 volts. Here I travel along conductor, back to where I started, there's no drop. You add up these numbers, 10 minus 526 minus 474, 0 volts, Kirchhoff loop. Okay. I've done two examples of two different combinations, and for each one, it kind of didn't follow the same procedure exactly. Just for one combination, I kind of stepped through the circuit, simplifying. For the second one, I kind of jumped ahead and looked at a parallel part that I could solve independently of the rest of the loop. Then I went and solved the rest of the loop. So review these examples of resistor combinations, because there's no limit to the number of different types of circuits that can be drawn. So the goal is not to is not to memorize a particular solution, but to understand the concepts, the steps, the principles, series, same current, parallel, same voltage, solving for series resistors, solving for parallel resistors, using the loop, the voltage drop through a resistor, the junction rule, how the current splits at a junction. Learn those concepts, learn those principles, so you can really analyze any particular combination of resistors. Okay, thank you for watching this video all the way to the end.